Hi my dear students, Assalamu alaikum to all. Once again, I warmly welcome to all in physics class. Okay. Yes, what have we learned yesterday or what have we learned in the last class? We learned about distance and displacement. I gave you a homework. All of you get the answers. What is the question? What is the question of you? Yes, our homework question is this. Find the distance and displacement of this. 4 meter here, AB 4 meter, BC 3 meter given in the question. Yes, how to find out the distance? How to find out the distance? Distance is equal to, yes, what? 4 meter plus 3 meter from A to C. What is the distance? 4 meter plus 3 meter, we get 7 meter. Distance is 7 meter. Then how to find out displacement? We know that displacement is the straight line distance from initial position to final position. So how to find out displacement? Yes, we want to find out this length. We want to find out this length, that is AC. We know that this triangle is right angle triangle. This triangle is right angle triangle. In a right angle triangle, how to find out this hypotenuse? In Pythagoras Siddhanta, Pythagoras theory, yes, we can find out the hypotenuse or AC. How to find out AC? We know that AC square is equal to 4 square plus 3 square. 4 square plus 3 square. What is the square of 4? Yes, 16 plus 3 square 9. 16 plus 9, that is 25. That is AC square or hypotenuse square. Then how to find out AC? AC is equal to square root of 25. What is the square root of 25? That is 5 meter. So we get this side or displacement. Displacement what? Displacement is equal to 5 meter. Did you get the answer? How to find out? Yes, distance is equal to AB plus BC. How to find out displacement? Displacement is equal to AC square is equal to 4 square plus 3 square, that is 16 plus 9, that is equal to 25. We know that root 25 is equal to, that is 5. So the displacement is 5 meter. In the last class we learned about distance and displacement. What is distance? Yes, distance is the length of the path covered. Distance is the length of the path covered. And what is displacement? What is displacement? Displacement is the straight line distance from initial position to final position. What are the difference between them? What are the difference between them? Yes, distance is scalar quantity. We know that distance is scalar quantity. And what is the displacement? Displacement vector quantity. Vector quantity means what? Yes, it have both magnitude and direction. So it's known as vector quantity. So which one vector quantity? Displacement. Displacement is the vector quantity. Then what is the other difference? Distance is the path covered and displacement is straight line distance from initial position to final position. And what is other difference? It can be equal in distance. It can be equal or greater than displacement. It can be equal or greater than displacement. But displacement, it can be equal or less than distance. That is one other difference. Okay. Today we are going to study about speed. What? Speed. Today we are going to study about speed and velocity. Speed and velocity. Yes, speed is very familiar word to us, is it? Yes. What are the major reasons for accidents? What are the major reasons for accident? Yes, we know that excess speed and careless driving are two major reasons for accidents. Excess speed and excess speed and careless driving they are the main reason for accidents. From this and we know that the word speed, is it? Yes. In your textbook, in page 77, we have figure 6.2. In this figure, we can here a person traveled to his office and returned to his home are depicted here. Is it? From this figure and here given the time also, if we given time also 600 second time from home to office and office to home also are given. In that time, what happened? All of you try to complete the table 6.5. In table 6.5, all of you take page 80 and complete the table 6.5 based on that figure. Okay, in that figure, a person first going to his office through, yes, through a hospital, is it? Yes. First reaching the office. First reaching the office, total distance. First reaching the office. Here total distance. Then we want to find out displacement. Then want to find out time. Time given here 600 seconds. Is it? Time here 600 seconds. Displacement per second. Next. Sorry. Distance per second. The next tab column displacement per second. Per second. See? Yes. Total distance, displacement, time, distance per second, displacement per second. There are two situations in that. Do you remember that? All of you look that figure. From that total distance, I can draw once again. Home, hospital, then office, then here ration depot. These are the way. 600 meter. These are 300 meter. 660 meter. And from this 420 meter. Here given 600 time also. Second 600 second time also. From first one on reaching the office. On reaching the office, what is the total distance on reaching from home to office? It is office. From home to office. From home to office, what is the total distance? What is the total distance path covered? What? 600 plus 300. What? Yes, 900 meter. 900 meter. Yes, one more thing for it. Here a straight line distance 480 meter. So, what is the displacement? That is, displacement is the straight line distance. So, from home to office, displacement 480 meter. Here, time given what? Time given 600 second in both cases. 600 second. Okay. Then, distance per second. Distance per second. Distance what? 900. Then by 600, what do you get? 1.5. Distance by per second 1.5 meter. Then what is displacement per second? Displacement 480 divided by what is time 600, so 0.8 meter. 0.8 meter. Got it? Yes. The next, on reaching back home. On reaching back home, what is the total distance here? From office to ration depot, that is 160 meter, and ration depot to home, that is 420 meter. What is the total distance here? 1080. 660 plus 420, that is 1080 meter. 1080 meter. First situation on reaching office, second situation on reaching back to home. Yes, here total distance 1080. Then what is displacement? Same displacement, so 480. Then 600 second time. What is the distance per second? 1080 divided by 600. What do you get? We will get 1.8 meter. 1.8 meter. Now what is displacement per second? Displacement 480, same. And times 600, we get same displacement. Is it? Okay. Yes, from this table, we write what are the total distance on reaching office and on reaching home. Total distance 900 ohm, displacement 480 times 600 given. Distance per second means total distance divided by 600. We get 1.5 meter. Then displacement 480, that per second is equal to 480 divided by 600, 0.8 meter. Then second situation, come back to home. What is the total distance? 160 plus 420, that is 1080 meter. Then displacement same. We know that displacement is straight line, distance of 480 meter, time given 600 second. Distance per second 1080 divided by 600, we will get 1.8 meter. And displacement like that same, we get 0.8 meter. From this table we can understand distance per second, that is the speed. How to find out speed? Speed is the distance per second, and displacement per second is the velocity. Displacement per second is the velocity. So what is speed? Speed is the distance travelled in a unit time. Speed is the distance travelled in a unit time. Then what is displacement? Displacement is the what is the velocity? The speed is the distance travelled in a unit time. Velocity is the displacement travelled in a unit time. Very simple, easy to understand. So what is the equation of speed and what is the equation of velocity? Speed is equal to distance divided by time, and velocity is equal to displacement divided by time. Displacement divided by time. Is the velocity and speed equal while travelling from home? Is the velocity and speed is equal? No, it's not equal. In which unit? What is the unit of speed and what is the unit of velocity? You know that how to find out unit? Unit of speed is equal to unit of distance divided by unit of time. What is the unit of distance? Meter. Time? Meter per second. Unit of time meter per unit of time seconds, or unit of speed per second. Then what is the unit of velocity? Same. The unit of displacement also meter. The unit of time is also second. So meter per second. Meter per Second, is it which one is vector quantity and which one is scalar quantity? Velocity is the vector quantity. Velocity is the vector quantity because it have both magnitude and direction. Okay. Next in your textbook have a question. To find out, calculate speed and velocity of the object. Calculate the speed and velocity of the object. What is the speed and velocity of the object? We know that from A to B, what is the speed? Speed, we know that distance divided by 10. 60 divided by 6, what? Yes, 10. 10 meter per second. And velocity? Also 40 B to C. Sorry, A to B velocity, displacement divided by time. Here distance and displacement have same. So 60 by 6, 10 meter per second. But velocity have both magnitude and direction. That is the difference. From B to C, speed and velocity same. 40 divided by 4, what? That also 10. But A to C, what is the speed? Speed is equal to distance divided by time. What is the distance? 60 plus 40, that is 100. 100 divided by 6 plus 4, 10, that also 10 meter per second. But velocity is equal to A to C, velocity displacement 70. 70 divided by 10, we get 7 meter per second. Here is the answer. Okay, from this we can understand what are the differences between speed and velocity. What is the difference between speed and velocity? Speed is the distance travelled in a unit time. Speed is the distance travelled in a unit time, and velocity is the displacement travelled in a unit time. And speed is scalar quantity, velocity is vector quantity. Velocity is vector quantity, and the equation speed is equal to distance divided by time. Velocity is equal to displacement divided by time. That are the differences between velocity and speed. All of you write that in your notebook. Next, this is the distance travelled a car. A, B, C, D, E and F. Yes, given 0 second, 2 second, 4, 6, 8, then 10 seconds. Here given distance travelled. Distance travelled, time, speed. We want to complete this table. Your book, page 81. Okay. So, what is Distance from A to B. A to B given distance 20 meter. Distance given 20 meter. Yes. From A to B, what is the time? 0 to 2 seconds, so time 2 seconds. How to find out speed? Yes, distance divided by 2. We will get 10. The unit meter per second. Got it? Then B to C. Same distance. Is it so? 20 meter. Time 4 seconds minus 2 seconds. What? From B to C. 4 minus 2 or 2 to 4. How many time take? 2 seconds. So we can write 2 seconds. Then speed. Speed we get 20 by 2. 10 meter per second is the unit. From C to D. 20 meter distance, time to second, 10 meter per second. D to E, that also 20 meter, 2 second time. D to E, 8 minus 6 or 6 to 8, how many time taken? 2 seconds. That's why we get 2 seconds here. Then how to find out speed? 20 divided by 2, that also 10 meter per second. 10 meter per second. Here distance travelled by a car is the same of a same time interval. Distance travelled by a car is same, the equal time interval. So this is known as, this speed is known as uniform speed. This speed is known as uniform speed. Is it? Okay. See, 20 meter. Yes. From this diagram, from A to B. A to B, what is the distance? 5 meter. 5 meter time 2 seconds. So what is the speed? 5 divided by 2 what? Yes, 2.5 meter per second. From B to C, what is the distance? 5 to 20 or 20 minus 5, that is 15 meter. 15 meter time 2 seconds. Same. 15 by 2, 7.5 meter per second. Then C to D. C to D, 20 to 26, which 6 meter, 2 seconds, we get 3 meter per second. That is 6 divided by 2. Then D to E. D to E, 26 to 44, 18 meter. 2 seconds, 18 by 2, 9 meter per second. Then E to F, 44 to 50 or 50 minus 44, we get 6 meter. That's time 2 seconds, 6 by 2, 3 meter per second. Here we can see that unequal distance have in equal interval of time. There are different. The distance travelled in a car is here different in equal interval of time. This is known as what? Non-uniform speed. This is known as non-uniform speed. Here we said that uniform speed and non-uniform speed. All of you get? Yes. If it travels equal distance in equal interval of time, it's known as which one? Yeah, this is known as uniform speed, and unequal or different distance in equal interval of time, it's known as non-uniform speed. Is it? Next, do you see the picture of this? What is the picture of this? This is the speedometer. This is the picture of speedometer. This speedometer is used to measure the speed in vehicles. Do you see this? Yes, it is used to measure the speed in vehicles. Then how to find out average speed? We know that speed is equal to distance divided by time. Then how to find out average speed? Average speed is equal to total distance divided by total time taken for the distance. From this case, what is the average speed? Average speed is equal to, yes, here what is the total distance? Yes, 50 meter. Then what is the total time? 10 seconds. So we get 5 meter per second. That is the average speed in here. That is the average speed in here. Okay. Are you understand today's class? Okay. We learn about speed and velocity. What is speed? Speed is the distance traveled in a unit time. And what is the velocity? Displacement traveled in a unit time. Is it? Okay. And speedometer is used to measure the speed of the vehicles. Okay. Yes. All of you study well and okay. Thank you. Let's wind up today's class.